Yes, the secondary of a 240/480 to 120/240 single-phase dry-type transformer is considered a separately derived system. This designation arises because the transformer provides electrical isolation between the primary and secondary windings. This isolation effectively prevents any direct electrical connection between the primary and secondary sides of the transformer. Understanding what constitutes a separately derived system is crucial for proper grounding and bonding practices, ensuring safety and compliance with electrical codes. When a transformer is designated as a separately derived system, specific grounding requirements outlined in the National Electrical Code, or NEC, must be followed. These requirements are designed to minimize the risk of electrical shock and fire hazards. The concept of a separately derived system is defined within Article 100 of the NEC. It is essentially an electrical source, such as a generator or a transformer, that has no direct electrical connection to the supply conductors. This isolation creates a new neutral point that must be grounded according to the NEC specifications. The grounding requirements for separately derived systems are primarily found in NEC section 250.30. This section dictates how the grounding electrode conductor, or GEC, and the bonding jumpers must be sized and connected. A grounding electrode conductor connects the separately derived system's grounded conductor, typically the neutral, to a grounding electrode. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded conductors. Bonding jumpers are used to connect the equipment grounding conductors, or EGs, to the separately derived system's grounded conductor. The size of these bonding jumpers is determined by NEC Table 250.102. In the context of a 240/480 to 120/240 single-phase transformer, the secondary side is considered a separately derived system because of the electrical isolation provided by the transformer's windings. This means that the 120/240 volt secondary must be grounded as per NEC section 250.30. Typically, this involves establishing a neutral point on the secondary side and connecting it to a grounding electrode through a grounding electrode conductor. Furthermore, all metallic enclosures and raceways associated with the secondary circuit must be properly bonded to the grounded conductor to ensure a low impedance path for fault currents. The reason single-phase dry-type transformers are listed for 240/480 primaries can be attributed to several factors. Firstly, historical reasons play a significant role. The 240/480 volt configuration was once a common voltage level used in older electrical systems. While 277/480 volts has become more prevalent in modern commercial and industrial installations, many existing facilities still utilize 240/480 volt systems. Therefore, transformers with 240/480 volt primaries are still needed to service and maintain these legacy systems. Secondly, cost considerations are a factor. Transformers designed for 240/480 volt primaries can often be manufactured at a lower cost compared to transformers designed for 277/480 volt primaries. This cost difference is primarily due to the lower voltage rating, which allows for the use of less insulation and fewer materials in the transformer's construction. In applications where cost is a primary concern, a 240/480 volt transformer may be a more economical choice. Thirdly, compatibility with existing systems is crucial. Many older buildings and industrial facilities still operate on 240/480 volt systems. When replacing or upgrading transformers in these facilities, it is often necessary to use transformers with the same voltage rating to ensure compatibility with the existing infrastructure. This is particularly important in situations where it is not feasible or cost-effective to upgrade the entire electrical system to a different voltage level. While 277/480 volts is more common in newer electrical systems, there are still numerous applications where 240/480 volt transformers are used. These applications include older residential and commercial buildings, industrial facilities with legacy equipment, and remote areas with limited access to higher voltages. In addition, 240/480 volt transformers may be preferred in applications where cost and compatibility are primary concerns. In summary, the continued use of 240/480 volt transformers is driven by a combination of historical factors, cost considerations, and compatibility requirements. While 277/480 volts has become the standard in many new installations, 240/480 volts remains a viable and necessary option for a wide range of applications. When selecting a transformer, it is important to carefully consider the voltage requirements of the system and the specific needs of the application.